to coordinate geometry. Topic number 4 is going to be about estimating radicals, okay? So the goal of this unit is to take something like the square root of 80 and without a calculator kind of know where that is within one decimal place, okay? And just like we did this in the warm-up today, the first thing that we talked about was, well, what are the square roots that we like, right? What are the square roots that we know? We call those perfect, okay? So when I'm talking about the square root of 4, I know that that's 2 because 2 times 2 is 4, right? If I look at the square root of 9, I know that is 3 because 3 times 3 is 9. So I'm looking for the numbers where when you multiply them by themselves, that gives you the number that's underneath that radical sign, okay? These numbers that I've listed here in purple, if you need to write them down in your notes, please do so because I'm expecting that you know these or that you're able to figure them out. So the square root of 1 all the way to 15, and then the square root of 400, which will end up being 20, okay? So you want to know what 10 squared, 11 squared, 12 squared, 13 squared, 14 squared, and 15 squared is without a calculator to be able to estimate these well. All right, so I've listed out some steps here for you. Why don't you pause the video and take a second to write these down, and then we'll go through them together, okay? So looking at example 1, okay, I have the square root of 80. So the square root of 80, the very first step is to find two perfect squares. And what I mean by that is I'm going to look at this list on the left here and figure out where 80 falls. And it looks like 80 falls between 64 and 81. Those are the two perfect squares that 80 is between. Okay? And so step 2 says to make a number line. So I'm going to make a number line, and I'm going to plot the two perfect squares, 64 and the square root of 81. And then I'm going to actually plot my number. So I'm going to say the square root of 80. Now 80, that's really close, right? Looking at step 3, that's closer to 81 than it is to 64. So I'm going to plot it a little bit closer to 81. I'm going to plot it right here, okay? Let's actually find how far away those are. So clearly 80 and 81 are 1 away from each other, right? And then 64 and 80, those look like they are 16 away from each other, okay? So how does this help me? Let's look now at step number 4. Step number 4 says estimate this to the nearest tenth, okay? We've kind of jumped a couple of steps here because it still looks a little bit complicated. I'm going to simplify this up a little bit. The square root of 64, that's actually, we know that's 8, right? And the square root of 81, we know that that's 9. So that means that the square root of 80 has to be between 8 and 9. So my answer is going to be 8 point something, okay? That's my number point something. So the nearest tenth means I need one decimal place. And let's think about what it would be. If I had something like 8.1, right? That would be a lot closer to 8, so that would be something that was way over here near the square root of 64. My value is actually very close to the square root of 81. It's really, really, really close to 9. So I think a great estimate for this would be something like 8.9. It's between 8 and 9, but it's very, very, very close to 9 itself, and there's my estimate. Okay, let's do another one. All right, looking at example 2, it says the square root of 20. All right, well, my first step was to look at these perfect squares and figure out which two it was between. It looks like I'm between 16 and 25, so I'm going to make my number line and plot those numbers that I have. I'm going to have the square root of 16 and the square root of 25. And I'm going to label where my number is. The square root of 20, well, that's kind of really close to the middle, right? 20 is 4 away from 16 and 5 away from 25. So I'm going to plot it somewhere around here, square root of 20, okay? It's 4 away from 16 and it's 5 away from 25, all right? We also know it's between what two integers? We know that the square root of 16 is 4 and the square root of 25 is 5. So the square root of 20 has to be between 4 and 5, so it has to be 4 point something. And now I'm going to use what I have up here in orange to figure out what that something is. If it was exactly halfway, the same distance from 16 to 25, I would probably put 4.5, right? But it's not really exactly halfway, right? It's closer to 16. It's only 4 away from 16. So it's not 4.5, it's a little bit underneath that. So I would say maybe 4.4 is a better estimate for that square root. All right? Let's do one more example together. Okay? So the square root of 150. The first thing I'm going to look at is what two perfect squares is that between. That looks like it's between 144 and 169. So let's make our number line. I have the square root of 144, the square root of 169, right? We're going from least to greatest, right? And let's figure out how we plot our point by seeing how far away they are from each other. So I think it's 150 is 6 away from 144, and then 19 away from 169. So I think this one is way closer to 144. I think this one's going to be about right here. Okay? And let's write down how close they are. So between 144 and 50, that was 6 units away. And between 169 and 150, that was 19 units away. So now let's estimate. It's definitely closer to the square root of 144, which is 12. And it's further away from 13, but I know it needs to be 12 point something, right? And so, what is that other decimal going to be? 12 point what? Well, if it's closer to on the 12 side, that means I want my decimal place to be smaller, right? Halfway would be 12.5. Something really, really close would be like 12.1. But this is a little bit, it's not like right next to the square root of 144, so I'm actually going to call this one maybe 12 point, I don't know, 12.2 or 12.3, right? Because it's not right next to 12, but it's definitely closer to it. Definitely closer to the square root of 44, okay? So take a second and you are ready to try homework number 2.2, which will talk about estimating radicals, and then I think you'll have a little bit more midpoint practice on that one too. All right, so good luck, and I hope you have a great night.